All right. Officially live. Waiting for you guys to get on here. So I'll chill here for a minute. Yeah. So what I'll do, just to make sure we're ready. I hope you guys had a good weekend. Planted my garden this weekend. What else? I don't know what else I did. I don't remember anymore. Played games on Zoom. Did not get our stuff prepared. So that's, could have been better. But I got it done this morning, so that's good. Don't know if any of you are showing up, which is totally cool. You can watch it later. Maybe. Definitely gonna have to edit this video, aren't I? Which is fine. Hi guys. Yay! I didn't know if anybody was gonna show up. Thought I was just gonna be talking to myself, which, already kind of am. So, good morning, Tucker, at 1 p.m. I don't know if you guys can tell, but I did a thing this weekend. I dyed my eyebrows, so they are now the color of my hair. That was something new. Sometimes you just gotta go with it. You just gotta roll. All right, waiting for a few more to show up before I start some announcements. Hey, Kennedy. I will probably edit this. Oh, thanks for asking, Nadia. I did, but not for my doctor, so I have the report, but that's a whole bunch of medical jargon I don't understand. Hi, Mia. My back still hurts, is all I know. It looks like a little bit more intense than my last one from 2 years ago, so I'm hoping they'll do something. All right, I'm going to start with announcements, just some things that I have for you guys. So I did not do a very good job of grading over the weekend, so I am planning to grade the beginning of this week. I know a lot of you guys have dropped or emailed me stuff. And in addition to that, as another note, I'm going to start putting stuff on classwork. So I'm probably going to have one drop for all of our previous assignments. So the visual representation, the problem solving, and the text analysis. That was from Unit 8. That way it's just all in one spot and I'll have all the directions there. I'll probably make one by itself for the concept explanation for climate change, which was the assignment from last week. And then also one for math. And I'll put due dates on there because I know you guys want to have a due date, but just know that you can always turn in late. Please turn in late. But once it hits that due date, that's when I'll put it in as missing. Okay, so that is helpful there. I do, for those of you who are going to be taking the AP exam, I sent out an email. I do want to do a Zoom chat with you guys, hopefully on Thursday, if that can work, and just kind of talk about that. And I want to do individual Zoom meetings with you guys before the AP exam. And then I feel like there was another thing I was going to say to you guys, and now I don't remember. Of course, I'm on here and everything is blanking. But let me go ahead. I'll start sharing for what we've got for this week. I'm probably going to stop with the questions, just FYI. So let's share my screen. All right, so you guys should see that now. This is scheduled for week, I have no idea anymore, but it's 420 to 424. Monday, we're doing this YouTube live lesson. We're going to talk about ocean warming and ocean acidification. Tuesday, Wednesday, you got time away from science unless you want to work on stuff or you haven't done anything yet. So get those done. On Thursday, I'm going to have open office hours with Mr. Zimmerman on Zoom from 12 to 2 p.m. I'll post that prior. You will have a lab to do. So I'm only going to do, I think I'm just going to keep on with that one lesson on Mondays a week, and then you're going to have another activity to do. So you've got a lesson and then usually a homework. So please remember about those homeworks that I did last week. There's going to be a lab, this HHMI lab, which I will show you guys after the lesson. It's going to be graded for a data analysis grade. And then Friday you'll have off. I added Saturday in here because it's Jackson's. It is Jackson's 6th birthday. So he's turning 6 in quarantine. And if you feel so inclined, you can make a video and send it to me to my email. Or we're doing a drive-by parade. Shouldn't say drive-by. A parade for Jackson at 11 a.m. that day. So just some of his friends and whatnot. If you really want to get out on Saturday and drive by the house and shout happy birthday at him. So just something to look at or think about. And here we go. So we're going to talk about ocean warming. Get rid of that. I'm going to attempt to present this again. If it doesn't work, we're just going to have to make it big. Why does it do that? That is the most annoying thing ever. All right, there we go. It works that way. I'll do it this way. So this we went over last week 9.1 to 9.4, which was the ozone and greenhouse gases, and then 9.5 is climate change, which is what you guys were doing. I posted a bunch of videos, and you guys did the concept explanation, or should be doing that. Now we're going to talk about ocean warming and ocean acidification. So that goes in with global warming, and some of this is repetition, and that's fine because it's always good to have more information or more times that we're going over it. So let's talk about it. These are the two standards. The data that I got is from this website, so you guys can go there to get it, but I shortened it and abbreviated it for you guys on here to get what you need. And this is what the standards go into for AP if you want to look back at them. All right, so let's talk about ocean warming. We know that oceans absorb heat. We know that they hold on to heat as well. They take a longer time to heat up and a longer time to cool down compared to land. But as the atmosphere gets more carbon in it, carbon dioxide, more methane, remember all the greenhouse gases, more water vapor, more nitrogen dioxide, I think, nitrous oxides, hey Noah, more methane, did I already say? And CFCs, all of that is going to increase the atmospheric temperature, and then it will also increase the temperature of the ocean. So what you're looking at right here, oh, sorry, I tried to make it bigger, but I couldn't. What we're looking at here, it says an anomaly. It's just an anomaly, basically. So these are temperatures that are outside of the normal average temperature for the ocean. So what we're looking at is it either goes above that normal temperature or below that normal temperature. And so the dates start, if I can get rid of this, the dates start in 1880 and go to 2015, I think. And so what you can see is that starting in the 40s, the temperatures started to be greater. And then went down. They kind of fluctuated. Now they've trended upwards to where they're above that normal more often. And so we're seeing that the ocean temperatures are rising. All right, so what's the problem? And I like this visual graphic because it just shows you the different things that are occurring due to having that increase in those greenhouse gases. So atmospheric temperatures are increasing, which also means the atmospheric moisture is increasing, because if you have a higher atmospheric temperature, you're going to have more evaporation. The land ice is decreasing because of that higher temperature. The amount of sea ice is also decreasing. And the mean sea level ends up rising for two reasons, really. We have the warming, which allows the particles to spread out, which is going to increase the height of the water, just because of that thermal expansion, but also because we have more ice melting and going in. So there's literally more water in there. The ocean heat content is rising, so we're going to talk about that. The global surface temperatures is rising. There's more extreme weather events that are going to happen, so more droughts, but also more flooding. Ocean mass increasing, again, because of the land and sea ice. Coastal flooding and erosion is going to increase, and there's going to be less snow cover in glaciers, so everything is melting. And again, some of those are those positive feedback loops that we talked about last Monday, so you can go back and look over those. But for instance, if the snow cover is melting, that means it's going to have a higher albedo underneath. So before, the snow would reflect some of that instead of absorbing the ultraviolet radiation, which means it can get back out. If it's ultraviolet radiation, it'll get back out of those greenhouse gases. But when it gets absorbed and then re-radiated, it's now infrared radiation, and that's what gets trapped. So we'll have a positive feedback loop. Once it gets warmer, more snow ice would melt or snow cover would melt, therefore showing the darker color underneath. All right, so deoxygenation is just a large word for saying there's not going to be oxygen in there anymore, which we already know. An ocean that is warming is going to lose its gases that are trapped in it. Just like a soda, if you sit it out and it's warm, all those gases are going to leave it. So there's less dissolved oxygen there, which is a problem. The sea level is going to rise due to thermal expansion of there and the ice melting, so it actually adding more mass. And that's going to be a problem for the surrounding areas. They're going to start flooding. Also the organisms there. So the fish that live in there, the different organisms in the ocean itself, the different birds that are there, and then there's also marine mammals that are there. They're going to have a higher level of deaths or mortalities because of that, because some organisms can't survive in warmer waters, all right? They have a higher rate of respiration, so there's already less oxygen. They can't survive that way. They could have a loss of breeding ground, so we are going to have a loss of organisms other than just the fish, so there's going to be less photosynthetic activity going on. Possibly, so it can go one of two ways. You can have an increase, but then you'll end up having a decrease as well. And so there's going to be less biodiversity because we're going to lose some of our habitats. You're also going to have a lot of migration happening to try and find favorable conditions somewhere else. And then we'll talk about coral reefs, more specifically with coral bleaching. So we'll look at that on the next slide. I think this is a really good infographic to talk about coral bleaching. So one, you have the picture of the healthy coral. There's algae in it. So we have these living things, they need each other to survive. The coral is that calcium carbonate backbone, basically like a skeleton. But that's what the coral is, and then we have the algae living in it, which makes it colorful. So when it gets too warm, the coral, gets stressed, and then the algae will leave the coral. They basically expel the algae, and their symbiotic relationship just cannot take place anymore. And so then what gave it its color is now gone, and it looks like calcium carbonate. It looks like that white color of bone. And so it becomes vulnerable, and it is now bleached. Now, it doesn't mean that it will actually die. A lot of times it does, but we'll talk about that on the next slide. And you can look at the reasons or what causes the coral bleaching on the side, but temperature change in oceans, which is the main one we're talking about with climate change or an increase in greenhouse gases. There can also be a runoff or pollution that can cause it, the overexposure of sunlight, or an extremely low tide, which would allow it to warm up more quickly, the water. All right, so warmer waters, they're going to expel the algae, like I said. They turn completely white. When a coral bleaches, it's not dead necessarily. It can survive the bleaching event, but just under more stress, it's subject to a higher relevance of mortality. So most of the time they will, but they don't have to. All right, what are some other issues with warming? The vegetation and the reef building species become impacted, such as the corals and the mangroves. So those things we know have roots, and they kind of help shape the coastline and hold the soil together that's underneath them. And so we have a more incidences of erosion and also sea level rising. This can destroy housing and also the other habitats that are on land. We will get more severe weather because of that warmer water. That warmer water is going to impact, and we didn't talk about all these weather systems, but we know that warmer climate can change and intensify different events. So we're going to have more droughts or more floods or more hurricanes, and then it can also change the intensity of El Nino. Another thing that is important now with what we're dealing with coronavirus is that it's going to increase the spread of disease in organisms themselves. So warmer climates allow for more vectors to kind of spread around and those things to survive for longer periods of time, bacteria, viruses, anything that can cause a disease. And so marine species are going to get it, and then humans, because we eat those marine species, we're around them, we could then get the diseases by consuming them, by the workers working there, or being exposed in those marine environments. All right, go ahead and ask some questions about that. I am going to start talking about ocean acidification, and then I'll go into the assignment. The notes are pretty short today, so yay for you guys. But if you have questions about the ocean warming, let me know. Again, here's a website for you where I got the information for the ocean acidification. So when there's more CO2 in the atmosphere, there's then going to be more CO2 in the ocean itself. All right, so same with the heat. If there's more heat, there's going to be more heat in the ocean. If there's more CO2, there's going to be more CO2 in the ocean. We obviously know there's water, and then we know we have carbonate ions, that are always there, and then that's how we get calcium carbonate. So this is one of the issues. Okay, so ocean acidification causes two different problems. One problem is the fact that we now have a more highly acidic ocean, all right? And we know what acids do to things, that breaks them down. So we'll talk about that. But also, because it is taking up this calcium carbonate ion or the carbonate ion, it will have less of that calcification happening. So we have lower incidences of shells. There's going to be less coral created because of this situation. So not only are we making an acid, we're actually taking away a resource for these organisms. So like I said on the last slide, there's more CO2 in the atmosphere, so there's more CO2 in the oceans. I got lazy and I did not put that into subscript. Sorry, guys. Calcium carbonate is needed for the organism shell, so that's that carbonate ion that we need. And then an increased acidity can actually break down the shell. So this is showing just an image of the breakdown after 45 days of, I think this is a butterfly snail. I can't remember the exact name. But it just shows how that is deteriorating the shell. So not only are they not being able to build it up with the calcium carbonate, but it's also breaking it down. That is ocean acidification in a nutshell, and the ocean warming as well. So again, type in questions if you have them, but those are those two standards right there. The next thing I want to show you guys to talk about is this. So again, remember we're going through all 7 of the scientific practice standards, and this is another one of them. So we've done the visual representation, problem solving, text analysis, concept explanation last week. Remember, we'd already done math. Now here's data analysis. And of course, I'm going to forget the 7th one, but I have it planned for next week. Oh, the experiment. Creating an experiment. Okay, so that'll be our last one. And then we'll have a test the following week. So we're getting to the end, guys. We're going to have one more week of lessons next week, and then we'll do the test the following week, maybe back in school, maybe online again. Who knows? But we're really coming close to the end. All right, so keep pushing through, and make sure you're taking the Unit 8 test, and get with me if you can. All right, so here's the assignment, and I just really want to go over it because I meant for it to be not confusing. And so I will post this in the assignment, and you will each get a copy of this, so you will answer it on here. All right, this is your answer document. Here's the standard that we're covering. All right, we're not going to quite catch all of these, but we're going to get enough, I think, here. So what you want to do is you're going to come here. You're going to be able to open this up. Hopefully these link correctly. I opened up the sharing so that everyone, you just have to be on your Viking mail, please. You're going to read through all of this, all right? That's step one, reading through all of it. And then when you get to the procedure and you have this open, you should be able to click there, or I have it right here. I'm asking that you only pick the top 3 on there so that I don't have to go through every single one, but we limit it to these 3 different islands. And this is the data that you're going to actually analyze. So in here, you'll click on these and it's going to download an XLS document for you. If you have trouble, just email me, please. All right, you're going to graph that data. And when we're here, there's a way to graph it, okay? So graphing instructions for openoffice.org. If you have an issue with that, please just let me know. It's really not the end of the world for me to send you what the graphs look like. Just send me an email, please. Again, I'm trying to give you guys a way to analyze data from home, and that is, I know, going to be a challenge. All right, so once you have them graphed, you're going to estimate the degree heating weeks. And so what that looks like is here. Actually, I'll show you this one. So you're going to have this data, and the ones that are above the curve, which is right here, would be that bottom line. That's what you're looking at. And so it's the number of boxes underneath there. So right here, you've got just the 1 box. You've got 1.5 here because this whole thing is a box. You've got 1, 2.5 here. And so you're going to use that data and add it. First off, you're going to copy and paste the graphs here. And then you're going to fill out this chart. So you should have data for 2002, 2010, and 2014. And what we're looking at is the degree heating weeks. All right, and you're just doing it for your own. These colors come into play. I am 99% sure these are the correct colors. So I'm going to have to go back when you guys answer the questions. But this is your part of, these 2 things are part of your data analysis. And then also this. So you're going to talk about the trends or patterns that you notice for your data. Do the degree heating weeks increase? And again, if there's more heat, there's going to be a higher chance of it bleaching. Then we're going to open up the world data map. Again, it should be linked. And this shows your 2002, 2010, and 2014. And you're going to look at the differences of the world, how they're changing. All right. And then you're going to answer questions based on the world data for the class. So this is for your data and then the world data. So what patterns do you see? What are some geographic patterns? So like, are certain regions more susceptible than others? And then what is the global trend? How is it trending from 2002 to 2014, from that first one to the last one? Again, if you have any trouble, please let me know. This is based on, can you describe patterns and trends? Can you explain them? Can you draw a conclusion from it? Can you interpret the experimental data? I'm not going to give you a hypothesis. I mean, I guess I could. Really, it's just if temperature is warmer, there's going to be a higher incidence of bleaching, coral bleaching. So that's basically the hypothesis. And then you're going to explain the data in the implications or illustrating the environmental issue. And the environmental issue here is coral bleaching. So you're going to have done that within your questions there. So that goes along. I tried to find one for ocean acidification. It just wasn't enough data analysis there. But if you would like to do it as a homework assignment, I can always add that. I'm sure you don't actually want to, but the coral bleaching, or excuse me, the ocean acidification one could be interesting as well. That is all. I'm going to video capture again. All right, I'm going to sit on here for another like 3 minutes to answer some questions, but other than that, that's what I have for you guys for this week. Going over the notes and doing this assignment and getting all your assignments done and all the tests done and maybe start working on some math. But that's all I got for you guys. Any questions? Did y'all leave me? Is that what happened here? Y'all signed in and then you're like, peace. Maybe. Yes, no, I have put the text analysis in there. I will, if you're not sure if you've done it, I will go, um, sorry. I am gonna post it in an assignment drop though, if you need to check and make sure that you've done it. Tucker, yeah, great that you got that. That's awesome. I will change it on the thing. No, it's pretty good. I ate raw cookie dough, so wasn't feeling that hot earlier. Probably not a good idea, but I mean, you live and learn. I've ate raw cookie dough probably my whole life. East whatever. My kids are currently yelling downstairs. I don't know. You probably can't hear them. You're so welcome. Maybe my question for the week, even though I said I was going to stop doing them, should be what is the over under on if we go back to school at all? I don't know if that's going to happen. I gotta wait just a little bit longer for any other questions or cantankerous statements from you guys. And then I'm gonna get to grading and posting and all that fun stuff. Maybe. I never know how to sign out of these things. Maybe I should do the whole like and then be gone. All right, I think that's probably the end of questions. Bye, guys.